Hi, welcome to my stream. Please send a plus sign to the chat if you see that the picture is good and the audio quality is good enough. Okay. So thank you for joining. I hope that we won't have any tech issues because I'm using all of this software for the first time. Yeah. So welcome to the Push video. And today, let me introduce myself. So my name is Igor. I've been working in software industry for like 20 years. I've been happily building Web3 for like past 2 years. I worked at a huge centralized exchange. Also, I'm a big fan of crypto and we're happily developing different kinds and different sorts of Web3 communication here at Push. And our goal probably is to compete with Web2 world with, modern cryptographic solutions. And today's topic would be probably all about decentralization, as you can see from the title. So let me talk a bit about what is decentralization. Normally, like you can decentralize at management level, you can decentralize at token level, you can decentralize your development process, and also you can decentralize architecture. And so today's presentation is all about like how can we achieve these decentralization goals here at Push and what options were available and what we kind of picked. And I'll show you some alpha demo code which works with a lot of nodes, so you'll see how it works and how it feels. So mostly this will be really deep in-tech demo, and we'll play a bit with JavaScript also. So that's it. I guess we can get started. Let me check the chat again. Oh, nice. So I think everything works as intended. Okay, so let's go on. Yeah. So first, let's talk a bit about different architecture types. So like we have traditional systems, we have crypto-related systems, and we have a lot of in between. So let's start with a client-server architecture. I hope you can see my mouse pointer. So normally you have like a front end, a back end, and a database. And you trust your infrastructure, you trust your network, you trust your nodes. You have full network control and full node control. You can upgrade code. And your database gives you state. By state, I mean you have ACID guarantees. So it's atomicity, consistency, isolation, and durability. And here, like you can just write your code and live a happy life. So let's go to the right side. So we have distributed architectures here. Mostly you don't have a single state. Your state is kind of distributed between different nodes, and you have a CAP theorem, consistency, availability, partition tolerance, and you can pick only 2 out of 3. Also, you might have like a very expensive data center, like one EU, one in US, and they communicate. And you pay for the network, you pay for the nodes, you control how much power, how much CPU power every node has, but still you can have network issues, network congestions, like communication failures between like Europe and Asia, whatever, and your nodes might fail, and when your nodes fail, you need to recover. And so like databases like Cassandra, they always kind of bet on automatic recovery because like in the first case in client server architecture, you can just call your DevOps and ask to, to recover the node. But in case of a distributed system where you have like hundreds of nodes and they're spread somewhere in the cloud between different data centers, so you need a lot of auto recovery because hardware fail, networks fail, everything fail. Yeah. So, and let's talk about peer-to-peer. So in client server, in a distributed, you can trust your hardware, you can trust your software. But in a peer-to-peer environment, like you don't know who's your peer actually is. So you can't really have trust between one node and another node. And you also, your network is completely unreliable, and every node can have its own CPU properties, disk properties, anything. Like you just don't know what might happen, so you need kind of to be ready for anything. And so here we have different kind of swarm algorithms. One of the most popular is DHT, distributed hash table. So for example, IPFS and BitTorrent, they rely on this algorithm. And like one example of like a swarm technique is like, for example, on IPFS, you want some specific nodes to cache specific content. And for this, they calculate something which is called like distance. So they take a public key from IPFS node and try to use game theory. We'll try to use economic incentives. And we don't have network control and we don't have node control, but everything is built in a way so that acting maliciously would cost you a fortune. So it just doesn't really matter in terms of like long-term profits. Uh, the common way of getting decentralized is just like having your blockchain. So blockchain is by design a decentralized database. And if we're talking about more complicated blockchain like EVM, Ethereum Virtual Machine, so here it's a distributed and decentralized state machine which can execute on like as many as like 500,000 nodes at the same time, and the scale is massive. And so it's hard to kill this network at once, and it's hard to really bring it down on the knees. So it allows you a lot. And so like we can play blockchain here, we can play smart contracts, or we can play cryptography in a way so that either blockchain or a smart contract would secure all the network. So if you want to get decentralized, you don't need to build every piece of your software on chain, but your blockchain or a smart contract can secure the network by using cryptography, by using signatures, by using like a lot of techniques. So that's the point. So mostly we go from trust to trustless systems, and mostly like if we have a single state on a single database to the right, like we just don't have a single state at any moment, like it is distributed across the network. So that's it. I guess we can go to the next slide. So yeah, let me check. Yeah, I hope video is okay. Yeah. So let's talk about motivation. So our goal was to build something which is like a permissionless system. By permissionless, I mean you can grab from our GitHub the latest version and just run it yourself. And so we want to be sort of proof of stake, so that if you own a push token, you can use that token to run a node. And whenever you run the node, like it only requires some hardware and some tokens. And so yeah, and also we want to utilize like gamification so that honest node operators would benefit from hosting a node, and malicious nodes would eventually get punished in some way or another. So it won't profit them on a long term. Yeah. So also we thought about like which nodes type could be here, and we're thinking about different type of nodes. So not like most of the blockchains, they have one type of node, but here we want to have like big fat nodes and light nodes and other type of stuff. Yeah. And yeah, I want to talk about scaling a bit. Like normally blockchains, they have like this, they publish one block, and then this block is propagated, and you have finalization, and you have all the stuff. And we want just to be able to have like multiple batches published at the same time, just because we want to be able to scale. Yeah, I guess that's it about motivation. Yeah. So most of our solutions are inspired by the graph. This is an RSM protocol, which is very popular at the moment. I hope so, if nothing changed. So we wanted to provide some APIs, and we wanted to validate the messages. So imagine that you have a channel and you have subscribers, and you want to notify everyone who has this subscription that, like BTC price is, it's a new hate, no one expected, but it is there. So you want to send this message. And so we need some validation, and we need some API to send the message and to check who's in the channel and to notify every user. And also you want to store and you want to index data. So somehow we want to be able to access something which has been sent like a year ago, and just filter it and examine it and whatever. And also we want to deliver messages so that whenever I send a push notification to someone, he will receive it. And for receiving, usually there's like an issue with last mile delivery. You need to use big tech APIs like Google API, Amazon API for that. Yeah. Also, we want to guard the network. So in order to guard the network, we want to use smart contracts, different types of smart contracts, but the idea is still like make the rules. So a smart contract on the blockchain defines the rules, what is good, what is bad, and if you are acting maliciously, you'll get punished. If there's too much data on a single node, it would like reschedule how the nodes should handle the data and they should comply with it. So the most logic comes on a blockchain. Yeah. And so shard the network, it's another issue, like how to split the data between nodes so everything would just work and not collapse when we will have a lot of users, because we aim to have a lot of users. Yeah. So here are like the design decisions which we took. So imagine we have validator nodes and their goal is to validate a batch of notifications. We have storage nodes and their role is like index data. We have delivery node and their goal is like maybe third-party integrations. For example, if there is a custom wallet which wants to send notifications, again, every user has its Ethereum address or some other blockchain address, and we want just to deliver the notification using the wallet. So there's no such thing as a mobile device, and the mapping between a mobile device hardware ID, which is required to send a notification normally in Web2 world. So this mapping should be altogether, everything should be handled by a delivery node, and probably delivery nodes should be hosted by some our partners. I guess that's so we don't need like a lot of them. Yeah. So about guarding the network, so these are smart contracts, and sharding, these are smart contracts. We aim at pretty fast delivery, I think like 15 seconds or less. And like on every stage, we want to utilize push token. So push token would be locked to run the node. Push token would be used to pay for a monthly fee, and also like all the rewards would come as a push token fees. I guess that's it. Yeah, I think I can go through there. Yeah. Yeah, is the video just a normal web app, and this SDK would allow you to send a notification to the end user using pre-created channel in our system. And so here how it works. So an SDK would just read some contract state, which is public. So like everyone on a blockchain or any other like web RPC user can just invoke this and can just read all the nodes. And so on this picture, I have like 1, 2, 3, 4 validators, 1, 2 storage nodes, and 1 delivery node, and an end user who is gonna get his notification. So the idea is that SDK somehow chooses the right validator. The validator publishes a block. You can think it's not like exactly a block, but like a batch of notifications combined. And so this batch would get handled by a storage node, indexed, and later you can access this. Or also it would get processed by a delivery node at least once. And so this delivery node could just notify the user. So imagine that we might have a lot of delivery nodes for different wallets, for different subsystems, and maybe a few delivery nodes for like just notifying using like a mobile number or something like this. So this is like a big picture. Like I guess there should be no really complications with this. So I have a more detailed picture. So let's go in, because this is again this is like a technical demo. So there would be a lot of technical stuff here. Yeah. So this is a deep dive. So we have a DApp or a backend SDK, and we have a push SDK, and this push SDK we have 1, 2, 3 validator nodes. We have a storage node, 1, 2, and we have a delivery node, 1 and 2. And so we have validation layer, storage layer, and delivery layer. And we have a bunch of smart contracts here, like a validator contract and a storage contract. So let's go one by one. So push SDKs gets an API token from any validator, so it doesn't really matter. And then with this token, you can access some specific validator and just provide him a notification. Like just one example, I want to notify everyone in my channel about this new thing, like, whatever the price is going up or down or anything. And so what happens? Every validator has like something like a mempool. And so it collects all the notifications for like 20 seconds or so. And then when the time comes, like a cron job, it would just publish this block. And in order to publish, he's required to collect approval from all other validators. Like imagine we might have a lot of validators, but for approval, we might collect just some percentage of them. And so whenever we have this block signed by multiple validators, we can publish it in the queue, and this queue can get read by storage nodes and by delivery nodes. And for storage and delivery node, we expect to have a big queue, like, we want to store our notification like for years. And for validator node, we want to have like a lightweight node. And so for this lightweight node, we would prefer like it, we want to save HDD drive space, and that's the idea. So validators are all about securing the network and keeping eye on that rules are going the right way. And so storage nodes are all about like storing a lot of content, really a lot. And delivery node is all about like just notifying. So you see in this network, we have this like separation of responsibilities. So we're not trying to build one big node which is responsible for everything. Yeah, I guess we can get to the next stage. Yeah. So this is the place for the demo. So I'll show it. Just give me a second. So here I have a bunch of nodes. We have a UI for this, but since this is a dev demo, I'll just show you how I create every node. So here I'll just, for example, I have 101 push token and I have a wallet. So here I will just create node validator 1 using this wallet and providing 101 push token, and the node would operate at this address. Again, I'll show you like around 10 nodes communicating on my local machine. So this is just localhost URLs. So I mean, imagine that here would be like some domain.push.org or something else. So it's not an issue really. So we have 3 validators. We would have a delivery node and we would have a storage node. So we are registering all these nodes. So let me show you. So this is an instance of EVM chain. So just a local blockchain running here. So, and here I have 3 nodes. So I have 3 wallets. Every wallet has some staked push tokens. And I have 2 wallets for storage nodes and 1 wallet for delivery nodes. So I have a network assembled already and sort of registered on a on the smart contract. So this is it. Yeah. And now let me show you how the nodes operate. So I have an SDK and I have 3 validators, 2 storage nodes and 1 delivery node. So I'll just start everything, and it's not that hard. I'll just start every node. I hope they would connect. Sometimes bad things happen. That's because there's a lot of machinery, like 10 different chunks of code are talking to each other, but I mean, normally my Mac works pretty good. So I'm running validators. So these are 2 storage nodes. This is a delivery node, and this is validator number 3, validator number 2, and validator number 1. I can show the same case on like 10 nodes, it just doesn't make sense for me to showcase everything because I run out of space. Yeah. Okay, let's just wait a few seconds. So the node will discover each other, and they would connect and they would start, talking. Okay, I think like 10 seconds is enough. So now let me show you how the SDK works. So here I have some TypeScript. I hope you can see my screen. Yeah. So this is a common like Ethereum RPC. So I'm just using a local host. I mean, again, I'm just saving on transaction costs and everything, so I can set up everything really quick. Yeah, mostly the testnet would be on Polygon, so yeah, you would be able to touch every piece of this architecture. So here I have like just a JSON RPC pointing to my local EVM. I have a signer with my private key, and I have an SDK. And the first thing I want to show you is just like I will obtain a token and I will ping a validator. So I'll just call this. So you see, I'm reading a list of validators from the smart contract, and I'm using one of them, and I'm getting this token. And this token allows me to call only this URL. Nothing else is possible here. So, I mean, it's just a specific token for an API call. Yeah. And so now I want to post a notification. Again, like I have my channel, I have recipients, I have my test message, and I have like the chain ID. Yeah. And its signature. Yeah, I'm showing like the most raw data so you can see. Normally it would be just a call with just this text. So it won't be so descriptive. So I'm showing you all the internals here. Okay. So let me send the notification now. Yeah, I'm sending the notification. Yeah. Okay, okay. So what happens? One of the validators gets this notification request with the right token, checks that everything okay, asks for approval from other validators, and then storage nodes, they're here. So they read everything and index, and then my delivery node should get data and it should send it. Yeah, yeah. And at the end, let me check. Yeah, so this node's responsibility is just to invoke like Amazon API. So it is turned off right now for the demos, so we won't see, but yeah, this is how it works. And now let me show you that every notification gets indexed. So I will comment out the sending part and I will show you the list inbox part. So I'm providing the address and I'm providing that I want like March 2024. That's it. So just checking the inbox and showing that something is there. Yeah, so I have 3 notifications here. Yeah, because the most recent one is number 3. And so here's how the indexing works. We can query every notification and we can like search them using different criteria. And this is it. Yeah, I'll show it again later, but that's I guess that's for this slide. I think this is it. Yeah. Okay, so let me explain more details here. So we have a working network of three types of nodes. Validator nodes communicate between each other, they talk to each other, they collect signatures, and they do a lot of complex stuff. Storage nodes index notifications, and deliver node, they just process it and like the last mile delivery thing, plus, like partners, integrations, wallets, everything. And every node has its own wallet, and every node can be, instantiated by some owner, and the owner is required like to pay using push tokens. So let's talk like what happens if validator is, behaving maliciously. Like you just downloaded our validator code and you just edited some parts and now it works for you and not for us. So how it works really? Since it is a decentralized system, so there is no trust between nodes, and all nodes operate like they rely only on cryptography or gamification or things like that, or a smart contract. So what happens? So validator node number one converts a message to some processed message, like expanding macros, checking the contents, and doing a lot of stuff. And he votes like yes. So V1 votes yes. And then he asks, like again, some random amount of validators from the network. So it is decided by, you know, we have a specific complicated data structure which decides like which validators to pick. And so we have this list of random validators, and like these are V2, V3, and V4. And so every validator should say yes, yes, and for example, this one says no, and now we have 3 yes and 1 no. And what happens? The block contains a lot of notifications inside, and for every notification we have votes from every attester. We call a validator who is required to sign our block as a tester. So we have some attesters, and for example, if the block has enough signatures, then both storage and delivery is possible. So the storage node can check that, okay, I have 4 signatures out of like 10, I'm happy, I will index it. A delivery node can check again. I see a lot of signatures. This matches the smart contract rules. That's okay. This is a valid thing, so I will deliver the notification. And so what happens if one validator says no? The rules, they work like this. Every validator who is in some majority, like saying yes, should vote against any validator who is in a minority, for example, says no. And it also works the opposite way. So if you have a majority who agrees on yes and there's someone who says no, you should vote against it. And the voting happens like the validator who proposes a block, he collects every other validator feedback, and then he has like a bunch of votes, and then all these votes, they go to a smart contract, and this smart contract processes it, and if he sees that, something is bad happening, he will report, like literally register a complaint against this node, and after a few reports, like maybe 10 of them, this node will get slashed, and after a few slashes, this node would get banned, and slash means we'll take like 1% of this node collateral, and ban would, probably take like 3% of this node's collateral, and we'll also unstake the node. So the node would just lose some percentage of its stake tokens, and it won't get any profits, and we'll also ban the address. So that's how it works. So we're kind of defending against malicious validators. Yeah, please give me a second. Yeah, so I think we can go to the next slide. Yeah. So also we have storage nodes. They have completely different goal than validator nodes. So validator nodes, they have a goal of being lightweight and defining the rules. And for storage nodes, there's one example here. So imagine that we have 1 million user inboxes. I mean, like we have 1 million wallets, and every wallet is sort of subscribed to some amount of channels. And so now we need to host these inboxes. Like imagine that you have a Gmail. So it's like this. So for every wallet, we'll have like a Gmail-alike data structure so that you can check what's there and search and do other stuff. And so we'll just map every mailbox to a shard. Like again, imagine that we have only 10 shards. And here comes like the sharding part. So if we would have just one node, let's start like we like just starting the network, we have only one node and we are not, having multiple replicas of the same data. So every shard would get hosted. Every copy of this data would get hosted on the same node as one. In case we would add a second node and we'll still keep replica count as one, the smart contract would recalculate the assignments, and so there would be some shards assigned to first node and some shards assigned to the second node. And so the more network grows, the more reliable network becomes. Like we can have hundreds of nodes and we'll have a lot of copies of the same data. And so, for example, if we have like 3 nodes and 2 replicas, we'll have, so this, for example, shard 1 exists on SN1 and shard 1 exists on SN3. So we'll have a lot of copies of the same shard, where shard means like some amount of data of some group of users. So, and here the node can come, the node can, go away and just forget everything. We'll have a lot of copies of the same data, like 10x, 20x, this kind of stuff. And we're going to store this data for like years. I can't say the exact number, but that's the goal. So whenever the network grows, a smart contract gets notified. The smart contract reschedules which node is responsible for which piece of data. And this piece of data would get assigned to like multiple nodes, as much nodes as we can. And so we'll have a lot of copies. And yeah, on this slide, I would explain it. So imagine that I want to do list, like I want to show an inbox. What happens? First, a validator, like this one, validator 2, he tries to figure out which storage nodes are responsible for which data chunks. And for example, he figures out by reading the latest smart contract events that, we have storage 1, storage 2, and storage 3 responsible for shard like 5. And so he would try to read all the replicas, and then he would compare the output. And if the output is the same for every storage node, then everything is okay. Let's just reply with the data and the data is consistent. But what happens if there is not enough data and there is no quorum? Like imagine that we can have quorum like 10 nodes out of 18, for example, or something like this. So it would just reply, there's something wrong with it. And also if there's just one node which fails to return the right data, like, or it's just offline or anything bad happens, so it can complain again. A validator, like this one, for example, he can report on storage node 2 for, for missing content or for not replying reliably, and collect, again, signatures from other randomized validators on whether they see the same picture, whether they can reproduce the same issue. And so if everything is like he intended to see, there's a smart contract which can punish the malicious node. And by punish, I mean making a report, storing this report, and when there's enough reports, we'll just slash this node or ban this node. So that's it again. This is the gamification part where we'll try to, to keep the stake of every node, and whenever node does something bad, we'll just slash it or ban it or do something else. So let me show you just one example. I'll just stop this node, like, just it is offline, no matter what. So I'll try to query again. Yeah, so you see we have 3 rows, like just 3 notifications, and we're queuing them, but there is not enough replies right now, just because I have so like a low amount of nodes, like, and the quorum is set to 2. If one node goes down, there's no quorum. I can't really reliably reply. But for example, if I would have like 10 nodes, like we'll still can get quorum like 6 out of 10. So 4 nodes can go down. So this is how it works. So here, validator is responsible for queuing storage nodes, for checking if they are working consistently or not, and there's a smart contract who watches everyone and who checks that everything's according to the rules. Yeah. So yeah, let me summarize. So we have a decentralized network of nodes, three types of nodes: storage node, delivery node, and validator node. Every node is responsible for its own, role, and everything is guarded by a blockchain. And also we support sort of sharding, scaling, and like the ability to have no trust between components. So I guess that's it. Let me check the chat. Yeah, I think you can write your questions. I'll try to read them and I'll try to answer. Yeah. So the block size is not limited currently. We can have large blocks. I guess it would be around like a few megabytes of size. So there's no like technical limit right now. I guess it would be all about the bandwidth which you need to like you know like we want like a soft real-time system, so 10 seconds is good. So I guess we'll just pick the right size, but of course it won't be limitless. Yeah. I guess how often will the blocks get validated? I guess 15 seconds, 20 seconds, something around that. Um, okay, the next question. How long after validation before the notification gets sent out to users? What happens in a reorganization? Again, I think the time which is required for a block to propagate the network would be same like like 20 seconds to do everything. So the goal is like to keep in mind like the 30 seconds are the upper limit. So we are not aiming at like waiting. So if you are invoking an API, you will see results like in seconds, not in minutes. That's the order. Yeah. So for network reorganization, let me explain. So we have, for example, we have a lot of validators. If validators go down, that's okay. We would handle it like in 3 to 5 seconds. I guess that's it. We will notice that validator is offline and we won't ping him. But if he got offline faster than that, probably an SDK would get an error. So there's no way to handle this. I hope validators would be online most of the time, but if it happens, we can react. But there's a limit on how fast can we react to this. Yeah. And for storage nodes, what happens for a reorganization? It's that simple. If storage node fails consistently multiple times, there would be a complaint from a validator. The smart contract would evict the storage node completely. And then if the storage node was responsible, for example, for shard 5, this shard 5 would get assigned like as a responsibility for other nodes. So definitely there would be some redundancy, like a lot of redundancy. Plus, if the nodes is unreliable, it would just lose the assignment in a smart contract, and there would be like a new layout, and the nodes would, again, it's like the smart contract says like, hey, node, you are responsible for shard number 5. Now, if you are not going to serve all the requests about shard 5 data, we'll consider you a malicious node and we'll again slash you, ban you, evict you. That's it. That's it. Yeah, so the next question. So if a person is totally unaware of the technicality of running nodes, just holding push and want to earn through staking and running nodes, any package or complete setup. We'll have a testnet soon, I guess. And yeah, this is a completely technical demo with an SDK with everything. You don't need to know this. Uh, there would be just nodes which allow you to send notifications, and so there would be like end users who wants to send these notifications, and these nodes they would just process everything. Like imagine that like instead of Amazon, like just normal users can run some nodes, and these nodes would support the notifications, like processing of notifications, delivery of notifications, and storage of these notifications. And they would get rewarded for this. I guess that's the main goal. Like you should get rewarded for hosting this node. Yeah, because sending push tokens would require like sending push notifications would require you owning a push token, and whoever operates like any sort of these nodes would also get push tokens as a reward. I guess that's it. Yeah. Any other questions? Or we can go to Discord and you can write your technical questions there. No? Okay. Okay, I guess we can. Oh, when testnet is coming. I can answer like soon. Yeah, I don't want to give the exact date. Yeah, we'll build a testnet. We'll see that, you know, people are happy operating nodes, and then we'll go to, full scale. As the push ecosystem expands to more chains, would there be provisions in future to scale towards non-EVM chains? Yeah, again, as a developer, I'm already aware that like we're like we're getting ready for Solana, I think. So is the mechanism similar to Beacon chain for choosing the validator which proposes the block? Yes, yes. So it's like we collect randomness, then we hash this randomness, and then we exclude all the nodes which are sort of they have not enough like pings from other online nodes. So it's like a network random thing. So we collect randomness and then we use that randomness. So the idea is that you cannot know which validator would sign the block. That's the idea. So imagine that we have a network of 100 validators and you are like a malicious hacker. You want to invest just some push, like buy like 10 nodes, add them to the network, and you want to hack everything. But you cannot, because we'll try to pick for every block, we'll try to pick the most unpredictable path so that you won't be able to do this. I mean, you need to attack more. Yeah, that's the point. What happens if a malicious validator pushes invalid notifications into a proposed block? Again, you need a quorum. So the block would collect, for example, 5 signatures, and all 5 would say yes or no for every notification conversion. And so, for example, if you are the only one who says like yes and it is incorrect, and everyone says no, they would outvote you. They would there's like a second round of voting, and on the second round of voting, they would kind of reply that, this guy is a minority and I'm against him, so I don't like him. So here's my signature that let's report on him, let's slash him, and eventually this information would get to a smart contract, and this smart contract would again just slash you. So that's it. I imagine validators will not be choosing which notifications to include, as there is no block limit. They would include all notifications every time. Yeah, the idea is like you have a bag of, we add them to this queue, and this queue gets propagated to other layers like store and delivery. So that's it. That's it. What specific hardware requirements are push nodes planning to have for validator and storage nodes specifically? Yeah, so I guess for validator, the requirements would be pretty basic, like, 1, 2 virtual CPUs, like 8 gigabytes of RAM, maybe 50 gigabytes of storage. That's it. For storage nodes, I guess it would be almost the same. The only difference is like probably for storage we would require like more, like 500 gigabytes or more, just because we want to store, I don't know, 2 years of data, 4 years of data. So that's it. So it just would be, more HDD focused than a validator node. Yeah, but they would be really lightweight because our network, again, it's not like Solana. It's more like we're just processing notifications here, and so we're not require like a 1 gigabit of fiber optics and 16 CPUs and a GPU there. So I guess would be just a common type of nodes. Yeah. Okay. I've tried to answer all the questions. I think we can end up here. Thank you for coming to my push stream. Yeah, have a happy evening. Thank you very much. There is a link to a Discord, so you can ask any deeply technical questions. Again, this was a technical session, so there was a lot of complications, but you don't need to understand them if you're ready to host a push network. This would be just a like a node backend application, and that's it. So it's all about how we're attacking the problem of going decentralized and what type of nodes are there and what type of guarantees are there on the network. So thank you very much. Yeah, have a nice evening. See you.